Hey guys, welcome back to ILR Performance. Today we're going to take this scummy old Tecate 4 cylinder and this broken Tecate 4 head, and we're going to turn it into a bitchin' 310 Big Bore kit. Hi guys, today we're going to take this worn out rusty Tecate 4 cylinder. We're going to knock the old sleeve out of it. We're going to repair this head. We're going to re-sleeve this cylinder and machine it out to a 310 Big Bore kit. So I'll take you through making the sleeve, getting the sleeve in, doing the machine work on the head, repairing the broken water neck, and when you're all done, it'll look like this. This is a blank sleeve. It's a sleeve made out of centrifugally forged cast iron, which is an ideal material for making cylinder sleeves. It's very strong. It doesn't crack very easy, and it has really good wear properties. We typically buy a combination of either blank sleeves. We keep blank sleeves in stock for a majority of sizes. We also have some sleeves already made up for high volume stuff like 310 kits or 250 replacements. For a one-off custom sleeve job or a special big bore kit, typically we'll buy a blank sleeve like this. We'll order the sleeve in the correct outside diameter. The inside diameter is a bit smaller than we want, and we'll adjust that based on the finished wall thickness that we want, as well as the bore size. So we buy these sleeves. Primarily we buy from LA Sleeve. They've been in the sleeve business probably longer than anybody else in the motorcycle business, and they always deliver a top quality sleeve on time. Once we have the blank sleeve, obviously we're going to need to put ports in it. The beauty of buying blank sleeves is that we're not getting somebody else's port design. If we want to move a port, if we want to leave a port out, if we want to add an extra port, we have the opportunity to do it in the sleeve right now before we put it into the cylinder. It helps us do a much better job of making sure the port timing is exactly where we want it, and any customization we can do here while it's on the bench rather than trying to do it while it's inside the cylinder. So this is what the sleeve looks like after we've cut the ports into it on the milling machine. You can see this is the exhaust side. You have the main exhaust port. You have the boost ports on both sides. When you turn it around, you have your main transfer ports. And then you have your intake with the bridge. This will be the rear boost port, your sides. We can set any of these port timing where we want. We can also set the cutaway here. So right now, this is pretty close to a replica of the Tecate 4 cylinder. However, our Dune port timing is already machined into the cylinder, so that once this goes into the cylinder that we were just looking at, the timing on the sleeve is already going to be set. The nice thing about that is that the timing is very accurate. On the milling machine, we can get the port heights within about 2/1000 of an inch. When you're in there with a 90-degree grinder grinding away, if you can get it within 5 to 10 thousandths, that's very good. Cast cylinders, the way they come from the factory, it's not at all uncommon for ports to be as much as a millimeter off from the highest to the lowest, and they can vary from cylinder to cylinder 20 or 30 thousandths. So this is going to put the timing right where we want it. When we get it in there, we're going to go back in, we're going to match the aluminum to the timing we've put into the sleeve, and that's going to give us our ideal port timing. So we need to machine this cylinder to a bore diameter when we're finished in here of about 4 thousandths smaller than the outside diameter of this sleeve. The point of that is we're going to heat this cylinder up to about 400 degrees. We're going to freeze this liner. That's going to make the liner shrink. It's going to make the cylinder expand. That's going to give us about 30 seconds to take this sleeve, drop it into this cylinder after we get it machined, line all the ports up, and when it cools off, we're going to have a press fit between the cylinder and the sleeve that's going to keep the sleeve from moving. and it's also going to ensure that we have really good heat transfer between the liner itself and the water jacket in the cylinder. So this particular sleeve, we check each and every sleeve to make sure, because our tolerances are very, very critical. This one is 390 or 3-inch 99 thousandths. Nominal diameter when we order these is 3-inch 100 thousandths. It's about 64 degrees in the shop right now, so this has shrunk a slight amount. So again, LA Sleeve produces just an awesome product. The fact that we can get these time and time again within 1/1000th of an inch is awesome. We always know what we're going to get when we get it. So what we're going to do now is we're going to take the cylinder over, and we're going to get it up to the proper size to put the big bore sleeve. You can see that this sleeve is quite a bit bigger. Here, let me get this over to the camera. You can see that our bore is going to be quite a bit bigger when we're done, so we need to punch it out. Since this cylinder has already been sleeved once before, you can see there's a rusty steel sleeve in there. We're going to take this sleeve out first. What we're going to do is we're going to put the cylinder in the oven, bring it up to 400 degrees for about 20 minutes, and then we're going to press the liner out. The liner is going to heat up as much as the cylinder, so the liner won't just fall out. However, the aluminum will grow faster than the iron. That'll give us a very loose press fit so that when we take the liner out, we're not going to do any damage to the cylinder like we would if we just put it in the press right now and force the sleeve out. The other option that I can do is I can put it in the boring bar and just bore all the cast iron out, but that just takes a lot of time. This way I can throw the cylinder in the oven, turn the timer on, I can go clean the shop, do some other stuff. When the timer's up, I flip it over, walk it to the press, knock the sleeve out, let it cool off, and then we'll go over to the boring bar and we'll punch it out. You can see that we've pulled the old liner out. Here's the old sleeve that we took out of there. It wasn't a very good job. You can see they have orange silicone in between the flange and where the aluminum was, which means that they didn't have a very good fit there. Probably gave them some grief. This cylinder looks like it's had a bit of a rough life anyway. We've taken the cylinder over to the sandblaster, cleaned it up a little bit so that it's not all dirty, and we're ready to take it over to the boring bar, punch it out to fit the brand new sleeve. You can see that the new sleeve is big enough that it doesn't even fit in the flange of the old one. So we're going to take out about a little over 1/4 inch of material to get it up to the size that we need for this one. Here we are over at the boring bar. This is a little Quickway boring bar. It's about as old as I am, but it was recently overhauled. It's a beautiful boring bar, does incredibly good bores, does a nice counter bore for the top. You'll see the finish on this thing when we get it pulled out of there. So we already know that we need to jump it up to 3-inch 100 thousandths, and then we need to be about 5 under that. So we're going to be about 3-inch 096 when we're all done. So we'll go ahead and chuck it up, and I'll show you how it bores through. All right, we have our cylinder clamped up in the boring bar fixture. I have the bit set. I've already centered the cylinder around the boring bar, and I made a light 0.02 of an inch pass just to make sure everything was straight and true. It was going to clean up real nice, which it did. So we'll go ahead and make the first cut. We have to go right at 200 thousandths from the old sleeve to the new sleeve. So we're going to do this at 40 thousandths increments. We're going to make 3 or 4 passes at 40 thousandths, and then we'll do 2 passes at 20, and then probably 16 for our finish. So let's go ahead and turn it on, and you can watch it bore. All right, boring bar shuts itself off when it gets to the bottom of the cut. We're ready to go ahead and bring the bar back up. We'll take another 40 thousandths off. We'll make a couple more passes. I'm not going to record all of that because this is a bit like watching paint dry. So we'll come back just after we've got it bored to finish size and we're ready to do the counter bore on the top. Here we have the cylinder all bored. We've bored it 4 thousandths smaller than the sleeve. We've cut the index in the top. The index is actually cut exactly the same size, so it just barely fits down in there because you don't want any clamping force on that, but the sleeve is too tight to fit in. So now we're going to deburr everything and we're going to put it back in the oven, put the liner in the freezer, and we're going to drop the sleeve into the cylinder. Okay, so the cylinder has been in the oven for about 45 minutes at 400 degrees. We put the liner in the freezer for the same length of time. We're going to go ahead and shut off the oven. We're going to pull the cylinder out. We're going to drop that sleeve in there. So we have to line the sleeve up really well. We have just a few seconds after we drop it in to get it lined up. So we want to get it close right off the bat, and we drop it in. And all right, we're looking really good there. That's it. It's not moving now. So the cylinder is shrinking back down, clamping down on the liner. When it does that, it will try and squeeze the liner up and make it move up while it cools down. So we're going to take it out of here. We're going to go put it in the press. We're going to keep that liner down tight while the cylinder cools off. We'll come back after we get that done. Here's our cylinder in the press. It's been in there for about 20 minutes. Go ahead and make sure it's cooled down. It's barely warm to the touch now. You can see we're pressing directly on the liner to keep it in there good and tight. So we'll go ahead and take the pressure off. And take it out of the press. This cylinder is kind of beat up. You can see that there's some damage right there, a bit around there. There's some more damage here, back here. When we flip it over, somebody was, I don't know how well you can see this, but somebody was prying on the corners. There's a bit of damage all the way around. So what we're going to do with this now is we're going to chuck it up in the lathe and we're going to face off the top and the bottom surfaces. We do that for two reasons. Number one, on this one we want to clean it up because the surfaces are damaged. The other thing is we want to make sure that the bore is exactly perpendicular to the gasket surface so that when it's bolted down and we do our finish bore, and when it's bolted down on the motor, the bore is exactly 90 degrees to the center line of the crank. That'll improve the efficiency and the life of the motor. So we'll go over to the lathe and chuck this up. Here's our cylinder. It's mounted on the mandrel in the lathe. You can see it grabs the center of the bore, picks it up between the head and the tailstock. This is going to allow us to machine off both our top and our bottom surface at the same time without removing it from the machine, so we know that the top and bottom gasket surfaces are exactly parallel, and we're going to go ahead and clean up those crappy gasket surfaces. Okay, let's take a look at this. You can see that we made our cut, but there's still, oops, get my finger out of here. There's still some cleanup that we need to do. Obviously, you know, some of the damage is deep enough. We need to take another pass at it, but that's what it looks like after it's made a cut. Normally, we'd only have to take one cut to make sure it was true. Took about 2 thousandths off on that cut, so we'll take another cut, and then we'll come back. We got our top all machined so that we have a nice smooth surface, everything cleaned up real good. Then we flipped the lathe around to the other side and did the same thing on the bottom. You can see now we have a nice smooth machined surface all the way around. There's no damage to it anymore. It's nice and flat, and it's perpendicular to the bore. We're going to go ahead and check our total cylinder height. Make sure we are where we want on that, and then we're going to pull it out of here, and it's ready to go back to the boring bar. This is what it looks like after it's been pulled off of the lathe. You can see we have real nice gasket surfaces, nice and square to the bore. Top and bottom. I don't know how well you can see, but we got a really good finish quality. And we are ready to do our finish bore. So we can size it to the piston. Cylinder board, we hone it to size, to the finish size. Right now it's been rough honed to the nominal size of the piston. We haven't set it for clearance yet. But you can see that there's a mismatch between the liner and the aluminum on both sides. You can see we have a bit of liner hanging down there in front of that port. And inside the cylinder, you can see there's a mismatch between the cast iron liner that we just put in and the aluminum. So what we're going to do now is we're going to take it over the porting bench. We're going to match all the ports to the aluminum and make sure that all port timing is correct. So cylinder's been matched. We go in and you can see where we match the liner to the ports. So instead of a big step, we have a nice smooth transition. We've notched this out, blended it in, matched the exhaust port, worked on all the transfer ports. So liner's in, ports are all matched. We did finish hone it. This is going to be a forged piston. So we ran a 320 grit finish hone on it at 2 thousandths clearance, or 2.5 thousandths clearance actually. And we are ready to clean it up and paint it. All of our big bore kits use a full piston crown. That means that the piston crown curves all the way out to the outside edge, just like a factory piston is. Instead of a lot of the big bore kits, they use a piston that has a dome and then a big flat spot on the outside edge, so you can use a stock head with a big bore. The motors run a little bit hotter when you have the style of piston with the flat around the outside edge, plus you don't get the proper amount of quench. So in order to run this big bore kit, we're going to need to machine the factory head out to the 73 millimeter bore. So we've got it set up in the lathe in our jig, and we're going to go ahead and cut the squish first, check its angle, and cut it out to 73 millimeters, which is our nominal bore size. And then we're going to go ahead and deck the top of the head off so that we know our squish is exactly square to the gasket surface. And then we'll go ahead and cut the bowl out so we get the correct CCs. Okay, so this is our head after we've finished all our machine work and we've painted it. We have a nice clean gasket surface. We've recut the squish angle, set the width of the squish band, and open up the bowl for the larger displacement motor. This particular motor is going to run pump gas, so we've set it back to stock compression ratio with the Big Bore kit. This head originally had a broken water neck on it when we got it from the customer. You can see that we've tapped out the head to 1/2-inch pipe, and we've threaded in this billet aluminum water neck into it. That's going to give us really good flow. It's going to be a good strong part. It'll be way better than the original part was. And if for any reason he ever damaged it again, he can just unscrew it, thread a new one back in there, and it'll be good to go. All right, you can see the cylinder is all back together. We've given the cylinder 2 coats of the semi-gloss black epoxy paint, just like the head. We put a new copper gasket in and a water drain plug, put all the studs back in. This particular motor is going back to the customer with a set of billet power valves, so the actuator mechanism is all assembled, and the valves have been timed and matched to the ports, and this is ready to go in the box and go back to the customer. Well, that's going to wrap up this video on building a 310 cylinder. If you like the video, please subscribe. If you have any questions or comments, put them down in the comments field and I'll answer what I can. Thanks, guys. Thanks for watching.